Hello guys, my name is Jeff Concepcion and we are now again at Thermodynamics 101. Maybe you are from my thermodynamics blog or you've just searched this topic on YouTube on how to do this, how to do that, what is this one, and what is this one. Actually, you don't need to worry because I'm here to explain to you one of the most important topic here in thermodynamics, and that is temperature. On this video, we're going to discuss temperature scale, thermal expansion, and gas laws. I think it will be a very long discussion, so without further ado, let's get started. So what comes first to your mind if you hear the word temperature? Okay, just keep that first on your mind and let us define first what is temperature. We know already the meaning of temperature, and that is just an indication of how hot or how cold the material, substance, or system is. There are three types or three scales in temperature. That is Celsius, Fahrenheit, and Kelvin. There is another type which is Rankine and more. However, we're going to focus on Celsius, Fahrenheit, and Kelvin because that is the widely used scales in temperature. So here's the table of different scales at the different situations. Also, take note of this formula. For conversion of Celsius to Fahrenheit, we have, and for the conversion of Fahrenheit to Celsius, we have this formula. Now that we already know how to convert Celsius to Fahrenheit and Fahrenheit to Celsius, and we just need to add 273.15 in order for Celsius to be a Kelvin. So I think we can now move on to the next topic, which is thermal expansion. Most materials expand when their temperature increases. One of the best example for this one is thermometer. Thermometer is a very tiny or what I call thin cylindrical shape that has a mercury or liquid inside, and when the temperature increases, the mercury inside or the liquid inside expands. For you to understand more, let me give you one example.
On a hot day in Manila at 313 Kelvin, an oil trucker loaded 37,000 liters of diesel fuel. He encountered cold weather on the way to Baguio, where the temperature is 281 Kelvin and where he delivered his entire load. How many liters did he deliver? The coefficient of volume expansion for diesel fuel is 9.5 times 10 raised to negative 4. Given that you have an initial value at Manila, initial volume of 37,000 liters, the volume of expansion of 9.5 times 10 raised to negative 4, and initial temperature of 313. On the way to Baguio, you have 281 Kelvin. What is the final volume of the diesel fuel when the truck is already on the Baguio? You have a formula of VF is equals to volume initial open 1 plus beta delta T close. Substitute all the values that you have on the given formula. So you will be having a final value of 35,875.2 liters.
Now that you know how to compute linear expansion, it is the same with the area expansion and volume expansion. However, the coefficient of expansion, it is just doubled in area and tripled in volume. Take note that beta is just approximately equal to 3 times alpha. Actually, you don't need to worry because most of the problems out there has already a given of coefficient of expansion, linear area, or volume. I think we're already done with the thermal expansion. Now let's continue to gas laws. There are 4 types of gas law. First is the ideal one, second is Boyle's law, Charles law, and Gay-Lussac's law. So let's start first with the ideal gas law. Ideal gas law is also called universal gas law, and it is just derived from the combination of three remaining gas laws, which is Charles, Boyle's, and Gay-Lussac's. For the Boyle's law, the constant there is temperature. So on the formula of ideal gas law, we just need to cancel out the temperature, and that is the formula of Boyle's law. Next is Charles law. Charles law, the pressure there is constant on a system. So it means on the ideal gas law formula, we just need to cancel out the pressure. So that is the formula of Charles law. The last is the Gay-Lussac's. The Gay-Lussac's law has a constant of volume on its system. So it means there will be no change in volume. That's why we're going to cancel out again the volume on the formula of ideal gas law to get the Gay-Lussac's formula. Let's try two more problems in order for you to understand more or to completely know how to use this formula. It is a bit confusing because you have this one, you have this one, and maybe you're confused what are you going to use on this specific problem. That's why I'm here to help you.
A gas occupies a volume of 400 cubic centimeter at 0 degrees Celsius and 780 millimeter of mercury. What volume in liters will it occupy at 80 degrees Celsius and 780 millimeter of mercury? Given that you have 400 cubic centimeter, temperature initial of 0 degrees Celsius and 273 in Kelvins, temperature final of 80 degrees Celsius and 353 in Kelvins, the pressure here is constant and only the temperature and volume change. So what are we going to do is to use the Charles law formula. We will derive the formula based on the final value of volume, which is V2. V2 is equals to V1 times T2 all over T1. So we need to substitute all the given information to the formula that we have derived. V2 is equals to 400 cubic centimeter times 353 kelvins all over 273 kelvin. So the final volume is 517.21 cubic centimeter. So if we are going to convert it into liters, we just need to multiply it by 10 raised to negative 3. So the final volume of this problem is 0.517 liters. For the second problem, we have an ideal gas is at 45 degrees Celsius, has a pressure 123 Pascal, and has a 5 times 10 raised to negative 6 mole. Compute the volume of ideal gas container. Given that you have pressure is equals to 123 pascals. Number of moles is 5 times 10 raised to negative 6. R is constant and that is 8.314 joules all over mole K. And your temperature is 45 degrees Celsius but 318.15 in Kelvin. We are going to use ideal gas law formula because you were given a number of moles and there is no change in properties of thermodynamics. Joules is equals to Pascal cubic meter. We need to derive the formula in order for us to get the volume. So the formula for volume is equals to number of moles times R times T all over P. Now substitute all the values that you have. So 5 times 10 raised to negative 6 times 8.314 Pascal meter cube or cubic meter all over mole K times 318.15 Kelvin all over 123 Pascal. So the answer is 1.07 times 10 raised to negative 4 cubic meter or 107 centimeter cube.
So that's how ideal gas law works. It's a bit tiring to understand the temperature on thermodynamics because there's a lot of topics beyond that temperature, but guys, what I can say, this is just the beginning, and the temperature is the fundamentals, one of the fundamentals of thermodynamics, so don't miss it, okay? Hoping that you understand what I have discussed here, and if you want to have more knowledge, more notes, and more problems, just visit the link down below, and that is my blog about thermodynamics. And for more videos, just visit this channel.